All right, everybody. So, yes, once again, a very good morning, everyone present out here. Greetings of the occasion, ladies and gentlemen. Welcome to Shanghai Cooperation Organization First Young Scientist Conclave 2020, Day 3. Well, we are here for the thematic session 2, Sustainable Energy and Energy Storage, which is going to be all about thematic networking and group discussion on future perception. So, before we move on further, there are a couple of queries which needs to be followed. As the networking can seed so member state collaboration for possible cross-border R&D projects in science, technology, and innovations, all the young scientists are requested to actively take part in the networking session, and they have to showcase their thoughts and ideas for future collaboration. At the same time, that's going to be based on this networking session. One or more participants or one or more presenters have to present roadmap for the next 10 years. So make sure you're being very attentive with so much of enthusiasm at the same time. So right now, I think we are all set to make a part into the next session, as we've already told the topic that's going to be sustainable energy and energy storage. So here, I'm going to welcome our moderator of today, Dr. Deepak Pinjari, DSC Inspire Assistant Professor, Chemical Energy Engineering Department, Institute of Chemical Technology, Mumbai. I request you, sir, to kindly conduct the session. At the same time, I would like to welcome again our chair, Professor B.K. Panigrahi, Indian Institute of Technology, Delhi, India. Over to you, Dr. Deepak.
Yeah, good morning, all of you. Basically, I does not belongs to the ICT Mumbai now. Can you hear me?
Yes, so we can.
Yeah. Yes. Presently, I'm working with National Center for Nanoscience and Nanotechnology, Mumbai, and I'm a UGC assistant professor. So just a correction at your end, Anchor, please. And yeah, many thanks for the DSD and IICT for organizing this fabulous event for the young scientist. And yesterday I have almost gone through all the presentations of the young scientists, as well as Professor Panigrahi's presentation of importance of grid for national integration, especially. So apart from the yesterday's presentation, I would like to share one topic which is nowadays very much of importance, and that is called as a waste to energy. And I think probably I'll just go through my few slides so that you will try to understand the importance of the waste management, and how it can convert into the energy, and what are the quantum of the energy that is more important, considering in SCO country, China and India are the high population countries, and it accounts for almost say 30% population worldwide, and the quantum and the level of waste which we created make a lot of or sometimes I can say huge problem on the environment. So whether if we can design or we can set up any kind of technology which converts waste into the say energy mode. I'll just share my screen for the time being. Can you see the screen? Hello?
Yes, sir.
Yeah. I'll just go through it. I'm not, I don't want to go into that because most of the faculty or scientists belongs to this category are more or less aware of that. So everybody knows the pros and cons of the solar energy, and its cons is majorly is say we require at least 1 to $2 per watt energy creations, and it cannot run into it cannot create the night energy. Then the wind energy has pros and cons, hydrothermal, geothermal, pros and cons for biomass energy. But our the main interest must be how one can convert waste into the energy. And I'll just go through this slide. This is very much important. MSW is a municipal solid waste. And here I'm considering case of Mumbai. That is one of the economic capital of India. So in 1 kg of solid waste, we can find almost 50% of food waste, then 7% say paper waste, then plastic waste, textile waste, and so on and so things. And whether if you take all account, this generally goes for the landfill side, and there are huge issues of methane gas releasing. So whether we can develop or whether we can create some technology. Yesterday, Dr. Patankar from ICT Mumbai Odisha campus has already given us a clue about using a catalysis for agro waste. So in this, he has gone further for creating nanocrystals of cellulose, and ICT Mumbai has already set up a plant of agriculture waste to the ethanol. But more than that, whether directly apart from the ethanol, whether we can convert or whether we can use the catalytic engineering processes or catalysis processes to convert directly this product into the say biofuel or biogas and so on so things. So this is typically the landfill side which we can observe in near about Mumbai. And I would say if you can't measure it, you can't manage it. So we have to quantify, and we have to do the number of calculations in a such a way that we can manage our economy, or which we can sometimes call as a circular economy. So these are some of the India's I would say the populations. We have 10 million. There are two cities, Mumbai and Delhi, considered of 10 million populations. Then Bangalore and Kolkata, 5 million. So overall, there are 41 cities having more than 1 million populations, and which creates almost 54,000 ton per day of waste. And if you use it properly, then there is a potential of creating almost 700 plus megawatt energy out of it. So the challenge in waste management is it's a dirty, having a smell, it has a soil, it has a moisture, then it has metal stone, then it has a polymer lesser than 50% weight by volume. So this polymer is not degradable apart from any other thing. So whether this polymer can be used for next generation. So we have come up with some plastic pyrolysis reactors, and where we have converted this plastic into I would not say the green oil, because it's a diesel most, and it can be used as a furnace oil for many boilers. Then you can find pyrolysis char and some of the gases which we can easily convert using catalytic processes. Another concept is coming is a microbial fuel cell, and it's a huge concept. And I think it's into the stages of research, and researcher across the SEO countries should come up and do better thing in this area apart from the pyrolysis. So the emerging techniques, that's the more important, is to say concentrated solar photovoltaics, concentrated solar radiations, particularly for chemical synthesis or any material synthesis, whether we can do advances into the geothermal energy, then the marine energy, then we can say hydrogen fuel cell, which whether this hydrogen fuel cell can be utilized, say, for domestic purpose. Then cellulose, already this topic has been covered by Dr. Patankar, cellulosic ethanol, biofuels from say algae or the microalgae or the lignocellulose, because if we convert lignin into the say any form of the alcohol or any form of the energy is going to be huge. So in final side, I would like to say as a moderator, I think we have to really work on, apart from innovation. Innovation is really important nowadays, but I think reinvent ourselves is more important by creating, say, by say reducing or by reusing, recycling, recovering, and redesigning the processes. Then definitely the resources that which we have is a limited and which can be utilized, uh, uh, which we can easily utilize. Now, this is my view apart from the presentation yesterday we have. Now, I would like to go with the Dr. Patankar. And hello, Dr. Patankar.
Hello, Dr. Pinjari. Very good morning to you.
Yeah, hi, good morning. Yeah, you too. So I'm interested from you whether we can enlighten us from, say, whether we can convert, say, agriculture waste using catalytic process into, say, ethanol or the gases, and whether this technology can be commercialized and how, and what kind of the requirement which we required, and how we can do any kind of collaborations with across the SEO countries and help each other countries for the next stage.
Yes,
Yeah,
sure.
please.
So while talking about this, I would like to talk about one case study which I had done like around 2 years ago. I had analyzed this US 2G ethanol, second generation ethanol industries, which were funded by the US Department of Energy. So these were industries like Rentec, UOP, Halder Topsy, Ziachem, REI, Myrant, right? Poet and Mascoma, Abegona. So all these giant companies which came up in US around 2000, I would say 2005 to 6, and then they went ahead in commercializing these processes to make 2G ethanol, basically for blending this ethanol with the petroleum-based gasoline, and then meeting the targets of 15% ethanol in for the carbon neutral kind of meeting those carbon neutral challenges. Out of them, sadly, only 4 to 5 companies succeeded. Like out of the total 25 or so companies which were funded by US DOE, which had got more than $14 billion in funding, only 4 to 5 of them succeeded. And this transition was mainly this failure was mainly attributed to the fluctuations in crude oil prices. So making this fuel like 2G ethanol or any kind of fuel from biomass, which has a calorific value almost one third of that of hydrocarbons, it is successful economically only when the crude oil prices stay above $70 a barrel. Like when it comes below $70 a barrel, it really becomes a challenge to compete with them in terms of the economics of the process. The 4 or 5 companies like Mascoma, Myrant, ADM, ICM, and API, which succeeded in US, they all succeeded because they had a wide portfolio of products apart from 2G ethanol. So they also made some chemicals which were going into the fine chemical industries. They also made some algal-based technologies, which are very new, and like there is no threat of variation in the prices of the resource as such for algal-based technologies. And so these companies who migrated into various domains apart from 2G ethanol, they were able to make a mark, and they were able to survive this competition with the downfall of crude oil prices. So what I want to stress here is, in order to make any successful technology, like for deriving energy out of biomass, we will also have to focus on some parallel streams which will give us high value but low volume products, and which will kind of drive the economics of like 2G ethanol or the bioenergy, which may be coming out of pyrolysis or gasification processes. Because of course, energy from biomass is a sustainable alternative. We have a renewable resource, but if it is not economical, then like only the sustainability doesn't make sense in many in hello.
Please carry on. Please carry on.
Okay. So the sustainability doesn't make any sense if it's not economical, and then these industries have to unfortunately close down. And so to make the whole process of deriving energy viable, it is important to make these alternative streams which will give high value and keep driving the energy operations. Uh, in that perspective, I think there is a lot of interest in developing new technologies which can utilize biomass easily. One technology which I demonstrated yesterday is using this solid phase catalyst, which can be recovered easily and which can be recycled, thereby bringing the process cost down significantly in making any chemicals or energy from biomass. But the problem again is this solid-solid interactions, because your substrate is solid and the catalyst is solid. And so we have to come up with, there is no fundamental kind of mathematical framework which kind of handles this unique reaction mixture of solid substrates and solid catalysts currently. Also, the conventional reactors which we use for suspended kind of reactants, which are basically in liquid phase with a homogeneous catalyst or a heterogeneous catalyst, which is in solid phase, those kind of reactors are again unable to handle this biomass processes, because in order to use the conventional reactors, we have to kind of suspend them in a solution, which is mostly water, and then getting the water out of your product is again a very energy intensive challenge in the downstream when we are deriving energy from biomass. And so we have to operate with minimal kind of moisture in the biomass, and at the same time use catalyst which can be recovered at the end of converting the biomass. And so from the fundamental research point of view, at the technology readiness level, I would say 2, 3, 4, we have to really think on how we can develop this new kind of novel reactor systems, and also develop this mathematical framework around this using this solid kind of reactions. Another aspect which with respect to the agricultural waste in India is that there is a lot of variance with respect to the seasons, especially in a country, in a tropical country, which has more than 3 seasons sometimes. I mean, the transition between these 3 seasons can also be called another season, where the yield of agricultural produce varies significantly with seasons. The agricultural waste available is also varying with the seasons, and so the quality of agricultural waste is varying with the seasons. And so if you are procuring the rice husk or rice stalk in January, and if you're procuring it in September, the moisture content in it is significantly different. And so the same process, it is very difficult to operate it economically with the biomass coming around the year. So basically, these industries currently who are working with cogeneration also, they typically have a stockpile of biomass where they kind of make it stay for around 8 to 9 months, and then utilize it just to reduce the variation in the processing. So these are the challenges which I would like to focus on with respect to the agricultural waste utilization field.
Okay. Before Dr. Deepak can take it forward, just one of my eagerness to know, what is the level of the energy we can produce from this biomass, particularly the agriculture waste?
Yeah, so agricultural waste is available around 600 million tons annually in India. The calorific value, yeah, so the calorific value of it is around 15 to 16 megajoules per kg. If you compare that with petroleum, which is 45 or almost 45 megajoules per kg, so the energy quotient which we can derive from it is really small. I mean, you cannot compare that to the petroleum, how much energy we can derive, like on the per kilogram basis. But the only thing is the resource is available locally, and you don't need to import it, and it's a little sustainable.
No, I'm asking this exactly to clear my doubt, because as Dr. Deepak has categorically told, if you look into the situation of North India, the Delhi and other parts, because most of the agricultural waste, they burn it, and that causes high level of pollution. So for the energy, so if we can come up with some proposal, okay, this will be the amount of the energy which can be utilized. Okay, that's fine. And so Dr. Deepak, you can carry on with the others. Thank you.
My question is to Mr. Lee. or maybe you can just enlighten us on, say, yesterday you talk about the creating a devices, smaller devices which will have, say, low energy consumption and low maintenance. Can you again enlighten us regarding, say, whether how this technology can be utilized across the SEO countries, or so? Please, Dr.
Okay.
Lee.
Uh, yeah. Can everybody hear me?
Yeah.
I think with the advent of five generation arrow, there is abundant electromagnetic energy in the urban city, I think. The EM waves is an important resource that can be reused as the solar energy and the heat energy. And the solar energy is limited by the weather and the time, but the electromagnetic energy is always present, I think. In my group, now we can harvest the EM energy to power the sensors that can collect the information on ambient light intensity, temperature, and humidity, and transmit the information to the receiving devices for display and backscattering communication. And I think these two technologies can particularly suitable for the intermittent nodes with mass access. But the problem is the electromagnetic energy in the environment is too weak. So, I think in the future, we must integrate the EM energy harvesting with the solar energy harvesting and the heat harvesting. I think is a challenge research. It's like the satellite. We only integrate the satellite antenna with its solar panel. Yeah. So in the future, maybe we can integrate the electromagnetic energy devices with the solar panel and the heat harvesting devices. And this is my opinion. And in practice, we can harvest the electromagnetic energy by a rectifier antenna and rectify surfaces. But so far, we can only harvest the power that is over 30 dB level, yes, negative 30 dB level. So in the future, our group will develop the devices and to harvest the power level that is more that is below the negative 30 dB level. So that's all my opinion. Thank you.
Uh, can you thanks for your opinion, and can you enlighten us again, say, considering the importance of solar energy in harvesting? So I think, what's your view onto that?
Yeah, thank you.
Can you hear me?
Yes.
Yeah, I'm interested, or rather, the group is interested to listen, considering you are the design aspect and design importance, or some of the few devices which you show us, and which has been manufactured or created in your lab. We are morely interested to listen what kind of other techniques which we should use to harvest solar energy for the benefit of the mankind, or we can say for the benefit of the SCO countries.
So yeah, I think the challenge of uh, the challenge to improve the level the harvest power level is to um, is to design is to design a device um, that can collect more that can collect more power in the environment. So so our current research is to design different sizes of metal surfaces uh, mm, to collect the uh, different current intensity of EM energy, and how to fabricate this surface to arbitrary platform is also a very important issue. So we now uh, mm, the the electromagnetic energy uh, devices should be flexible, and our current design, the dielectric, the thickness of the dielectric is about 0.02 millimeter. So it can inflect it can fabricate to arbitrary platform. And in the future, we can use these devices to variable um, to variable systems. Yeah.
Uh, Thanks, Dr. Lee. Now, I just request Dr. Lu from Yunnan Academy just enlighten us the new approaches or the new areas which we can think apart from the collaboration, say on the innovation side, whether we can come up and we can develop such kind of devices or such kind of technology transfer so that the efficiency level of any devices will come up. So in considering, if you consider solar PV, the solar PV's efficiency at the moment is say lesser than 15%. Whether we can increase those, or say if you consider biomass energy has their own costs. So considering, take one example of one energy source and just enlighten us. Dr. Low, Miss Low.
You.
Yeah.
Yeah, thank you very much, Dr. Pajash, for the question. In my opinion, we found solar PV energy is quite useful and has the potential to be commercialized in large scale in India. In my opinion, I think, for example, the solar PV farm or the PV power generation farm, distributed solar PV uh, system, power generation system, and also the solar water pumping system could be very useful in India, because we know India has also a huge population and it requires a lot of food, for example, and we know the large area of planting needs water urgently. And we have actually done several demonstration solar water pumping system in India, and it has very good feedback from the market. And there are a couple more companies who would like to have more investment in this area. So this is, I think that's why solar water pumping system could be very useful. And also the distributed off-grid power generation, PV power generation system could be very useful, because we know like India is a huge piece of, has huge piece of land, and households are sometimes scattered around the urban area. It's not in the like very centralized place. So it can be very, it can be very expensive if we want to grid connect everywhere and deliver power to each household. That's why the distributed off grid, for example, the roof can be used as the power resources. to generate power and bring each family enough power. So that's why we think the BIPV materials and other type of building integrated PV power materials can be also commercialized in India. That could be a very good start. Thank you.
Yeah, thank you. Can you again, or can you enlighten us in storage system, energy storage system?
Storage system?
Yeah. And how, like, basically I'm will be interested to listen about say considering all the SEO countries come together and do something. Say now China is one of the powerful country in the world, especially considering the lithium ion batteries,
Oh,
because they
okay.
have gone up. Yeah, they have gone up like anything. And what kind of the innovation we can expect in this area, and how one can go ahead or and collaborate with SEO countries, considering India, Pakistan, Uzbekistan, China, Russia, and so other countries. So just please enlighten us onto that,
Oh, okay.
please.
Um, we all know that the energy storage, like normal storage battery, could be very expensive if we want to apply to the sustainable energy. That's why in large scale power generation station or the sustainable energy station, the storage battery is not a good option. Uh, in this area, I think we have some research on adding graphene to the traditional battery, so it can have a larger uh, input and output volume and shorter charging time. But I think in the future, the storage equipped sustainable energy power generation would not be very promising uh, path. Instead, I think the VPP or the virtual power plant could be a solution. It's getting more, actually generated from the Germany, and it's more like a micro system using the internet to dispatch the peak and the weak hour of output and use resources from different places. It's more like an still in a very initial stage and idea stage, but it can make the full usement of the SPAR sustainable energy. We all know that making the sustainable energy into the traditional energy grid can be a very can bring a lot of risk to the power grid, and the VPP system can somehow solve this problem by estimating the peak hour, the weak hour of the grid, and supply the spa power from the sustainable energy to the power grid. It based on the, of course, the communication technology, the five generation communication technology, and also some calculation on the cloud, etc. So I think this could be a solution, but we're still working on that. Thank you.
Yeah. uh, Dr. Lee Hay is online. Dr. Lee Hay.
Sure, I'm here. Thank you.
Yeah, yeah, yeah. So I think you are working in the photothermal catalytic processes. Are you a chemical engineer?
Sorry?
Are you a chemical engineer?
No, I'm a materials chemist.
Material chemist. Oh, material chemist. That's very nice and definitely a big area. So I think you works in the catalytic area, right?
Right, CO2
Yeah, yeah.
reduction.
Yeah, yeah, yeah. So I think nowadays, I'll just give one example about the plastic pyrolysis. If you pyrolyze mixed plastic under the ambient conditions, and definitely you required a good amount and good quality of catalyst. And I think Dr. Patankar may add into this after Dr. Lee has opinion, or Lee has say the talk, or maybe a 5 minutes or 10 minutes or something. So what I would like to, I'm interested in plastic paralysis in India, or some of the African countries, considering Nigeria. They have a plastic paralysis plant, and if you use the mixed plastic, there is a chances that suppose out of 1 kg of plastic, you get close to 600 of ml diesel, and the remaining 200 gram is close to 200 gram is char, or the plastic carbon char, and 200 gram close to uh, what we can say almost viscous product, or
Mhm.
sometimes it is called as a wax. So
Right.
being a material chemist, wax, being a material chemist, can you enlighten us whether there are technologies, or whether we can come up in collaboration with some of the technology which come together and develop such kind of catalyst, which definitely converts almost 100%, apart from the char, 100% say plastics to oil, which can be utilized for again as a furnace oil. Please.
Thank you. So first of all, I would like to say this is really a tough question. So because but it could be possible if we can do it indirectly. First of all, if we like just use solar energy to blend the not blend, like just convert it the plastics or wax into like CO2. I think that's something we can do. We make it to CO2, and then we use the solar energy to convert the CO2 into like fuels, and that's why I want to believe in just what my research talking my research. So my research is use
Please.
CO2 and renewable hydrogen. So we use only sunlight and then the CO2 and hydrogen to make oils. Now we can make CO, we can make methanol, and if we increase the pressure, we can make like C2 compound, or we can also continue with the CO and plus hydrogen, and we can make more like compound. So I think the advantage of this photothermal catalysis is that first of all, it actually can use more sunlight. You can use UV light, you can use all visible light, and you can use IR light because it's a photothermal effect. All portion of light can be used. And the second, this photothermal catalysis is connected to other renewable sources. For example, we need hydrogen, and this hydrogen you can make from electricity, solar electricity. You can also make like the wind electricity, or make or like different kind of renewable energies. And as mentioned by previous speakers, I think the storage of renewable energy is always a problem. Basically, you can make a lot of solar electricity, but how can you store it, right? And it's a big problem. It's not easy just power the solar electricity to the grid. So I think if we can use the electricity, we can convert water into hydrogen, and then convert this hydrogen and CO2 into like chemical fuels. And the chemical fuels, is much easier to store for large scale storage. And back to the questions, think ideally if we can have a like direct way, if we can have a catalyst to directly convert the wax or the plastics into fuels, that would be nice. But I'm not sure what this technology is feasible at this point. And if this is not feasible at this point, we can still just convert the plastics back to CO2, and then use this photothermal catalysis to convert the CO2 into fuels. So that's a two-step. And ideally, if we can just like during the process of converting plastics to like the CO2, so we'll release a lot of heat, I guess, right? And if we can use this heat, and then I think that'll be a much better option. So basically, you collect the heat from the plastic to CO2 conversion, and then you use the solar energy to convert CO2 into the fuels. And ideally, this process could be feasible because you don't need extra energy. And actually, at the end of the day, you actually convert waste into chemical energy, into fuels. You can use these fuels to power your car or essentially anything else. Yeah, I think that's my opinion. Yeah.
Yeah, that's a great opinion. I think Dr. Patankar, please,
Yeah,
may add
sure.
into this. Yeah.
Yeah, so I would like to share my one or two experiences in pyrolysis, working with these companies who are involved in pyrolysis operations. So basically, we tried to increase, as Dr. Pindari said, increase the yield of the pyrolysis oil and reduce the wax. Now, this wax, it comes basically from the unsaturation and also the oxygen content which is there in the framework of the polymer. And so mainly it is a function of what kind of polymer is there, which we are trying to like kind of decompose, or I would say make kind of oils out of it. And then we were able to get higher yields of oil by using noble metal catalysts, like like more the noble metal like ruthenium maybe. Better was the yield of pyrolysis oil, but again it's a kind of a balance between the cost of the process, like the
Right.
cost of the catalyst versus the yield of oil, which you would kind of like to increase. And so one area which I would definitely like want to collaborate is on developing new catalysts, which is mainly getting the right proportion of noble metal and non-noble metal to balance the activity versus the cost of the catalyst, such that we can have good enough yield of pyrolysis oil to make the process economical. And then developing this new catalyst is going down again to finding new combinations of metals which will reduce the cost of the catalyst. Uh, and yeah, as Dr. Hayes suggested, gasifying, like instead of the pyrolysis, the second option of gasifying, maybe the arc gasification, and converting everything into CO2 and then making into the chemical. So if that link is successful of making chemicals from CO2, definitely it is much better than the pyrolysis technology which we are trying to run right now. Because if we are able to make CO2 and then make chemicals out of that straight away, the yields and profitability will be much better in such processes. So my two submissions will be, yeah, for the pyrolysis processes, increasing the yield of the oil. One area is on developing bimetallic systems which can bring down the cost of catalyst, at the same time increasing the yield of pyrolysis oil. And second is developing gasification technologies which can make CO2, and then the second stage is CO2 to chemicals. So if we can focus on the CO2 to chemicals, that is one missing link in this utilization of mixed plastics.
Yeah, good,
Yeah.
good. I think yesterday one of the speaker from Russia, Professor Eli, talk about some composite material which can be utilized as a good one of the good adsorbent for say storage of methane and hydrogen. I think today he is probably is not available. I think this is one of the area which is again of importance, considering if you are like say we want say hydrogen fuel cell or hydrogen based electricity or hydrogen based say vehicles, hydrogen gas based vehicle. Can anybody enlighten into this? Miss Low is available. Can anybody enlighten? Because I think this is one of the potential area that I think will be really useful. As like Professor Lee has already talked about the devices, play low energy consumption. Maybe anybody can just come up on. Maybe you can have your wide thoughts and just to put. Maybe you can just your wide thoughts, please. Anybody? Professor Lee or Professor Patankar? You understand the question or
Yeah,
not?
yeah,
Yeah,
yeah.
yeah.
So
The
with respect,
huh,
yeah.
yeah, yeah, please. Please go ahead.
Okay, so with respect to the hydrogen, one interesting aspect, I mean, apart from the technology to generate enough hydrogen and storage of it, one important safety aspect which always has been the underlying thing
Yeah,
prohibiting this technology is the an issue that we have a 70 bar tank behind us. So that aspect, somehow people are not able to get over that aspect of using hydrogen in like automobiles, for example, or like running a bus on it. So I think someone specialized in that area, if they can highlight on that aspect of safety with respect to usage of hydrogen in in the mobility on surface, like I think that is the biggest mental block in using the hydrogen technology so far. Because yes, of course, people have demonstrated that it is a viable option. They have demonstrated that there are cars running over it, which are being shown, but the safety aspect of it is something which the experts have not been able to satisfy the customers, I would say, so far.
Yeah, yeah. Safety is a big concern considering hydrogen fuel cell. Now, like this is open questions to all, everybody considering this session. I think on the last day we have to, or in fact, you all of should come together and needs to give one presentations that how and that is majorly on, say, what are the goals of the SEO countries considering the energy, sustainable energy, or the energy storage area. Then what kind of the things which we can collaborate each other considering the strength and weakness of our SEOs. I think we need to come up one very good presentation. I think one of you can lead into this. Probably, I think Professor Lee or anybody from. I think there are only four presenter available today, and I think other I don't know the young scientists where are they at the present. I think one of you has to come, or maybe all of you has to come together and need to present a very good presentation, which will consist of a proposal, a very good proposal. Second, very good proposal, say for say collaboration. Number one is a collaboration. Publication patents will come up. That's not a big issue. But again, the major goal of the SEO or this conclave is whether there are particularly energy area which we are focusing at the present. What are the lacunas? How one can come up? What are the research areas? What are the technology available or needs to be invented or reinvented or redesigned, remodified? I think this presentation, we obviously I will guide into this, but this presentation you have to give one of you, or maybe two or three of you have to give on 28th in the morning session. So I think what kind of idea you guys have for that? Professor Lee. Dr. Lee, can you hear me? Hello? Hello? Dr. Saurav, can you hear me?
Yeah, I can hear you.
Yeah, yeah.
Yeah.
What kind of idea that which we can think?
I think one idea is on like the CO2 to like chemicals and therefore energy, which kind of was a topic of interest from at least three presenters yesterday. We can think of some new projects around that area, which is like CO2 is a common concern everywhere in the world. So utilizing it for material like chemicals and energy will be an important aspect. Also the CO2, if we are utilizing it, also kind of reduces the I would say the guilt of thermal power plants in some respects if we are able to utilize the CO2. And so forming some projects around CO2 utilization will be key in this partnership, I suppose.
Professor Lee, what do you think?
Yes, I think I agree, because I think if we can use CO2 as feedstock and then use solar energy, we combine CO2 solar energy, if we can make like value added chemicals, we don't need to even make fuels, just make something like economically feasible, like something is expensive, something is value added. I think this is really doable. And yeah, I think if we really want this technology to be used practically, we have to make money. So it has to be a technology makes money, then it can work.
Yeah, yeah.
And because solar energy is free, and the CO2, basically, I think we do have, well, every country has CO2 problems. We want to control the CO2 emission, and why do we just use CO2 as feedstock? So instead of waste, we can use it as like a feedstock, and then we convert it to different kinds of chemicals. Of course, this is not easy, but I think something we need to try. Yeah.
Because whatever the sources which I have, because I know this energy or the storage area, the SEO countries are going to put at least $1 million as a project funding, and they need to come up with a very good proposal, because from this conclave, I'm their part from the first day.
I see.
So the whatever the I know from the India side, $1 million funding is going to be the available for this. So accordingly, you need a kind of a proposal which they will be happy to agree on the final day. So I think
I see.
Professor Lee, can you enlighten what kind of the things which needs to be done?
Yeah.
Yeah.
Yes. Yes. In my opinion, I think maybe we should consider this problem from two aspects. One aspect is we can harvest the solar power, heat power, or the electromagnetic power, yeah, and another aspect, we should show something to reduce the power consumption. Just like in my report, our group used the backscattering communication um, to reduce the communication consumption. So I think in the presentation we can we can present our idea from these two aspects. That's all. That's my opinion. Yes.
How we can think of coming up with one proposal, considering all the aspects. Anybody has some kind of idea into this? Now, at the moment, only Indian and Chinese are available for the discussion, and I think we need other Russians or Pakistan or the Uzbekistan guys to come up and do something. Whether you guys or you being a scientist or the academician have that kind of linkage with other SEO countries. Hello. Now, do you have any kind of collaboration? Yesterday, somebody has a collaboration with the Indian guys. Yesterday, I have seen the presentation, but now the person is not available. So, what we obviously your suggestion are welcome. So I think Dr. Patankar, may I request you to at least create a small group in the
Yeah.
energy and energy storage, and just email each other to come up with some very good proposal at the end of the this conclave.
Yeah, we
And
should be doing that. Yeah.
yeah. So this will have an aspect of every countries, or I would say every energy aspects, more or less, so that everybody can collaborate and everybody can do something. Or maybe 2 to 3 proposals are welcome at the end of the presentation, I think. And also you should look into whether on the final day presentation, maybe somebody has to be a token, then everybody come up and everybody will fill the gap. So accordingly, I think you can exchange an email, and probably I'm there to guide you. And obviously my email ID is available into that, available to the email which everybody has already received. So probably I think we can start preparing some of the protocol or some of the things, so that the presentation on 28th by any of you will be really useful, and this session will be enriched by the experts which are supposed to become on the 28th.
Yes. So I think we should also try to use the chat window which is given in the kind of networking area for the sustainable energy and energy storage. So there is a separate chat window created over there. I think we can use that space as well to start the discussions around the projects. And definitely we can, for the detailed one, we can use the email communication as well for
Yeah,
one-to-one
yeah,
basis.
yeah,
Yeah.
yeah.
So yes, Dr. Pinjari, we have the live audience right here. So if you have any question queries, we can have the proceeding part done. Any
Yeah,
question queries, everyone?
yeah, yeah, yeah. Those questions are welcome.
Let's have interaction part done.
So any further discussion? Yeah.
Yeah, so thank you for giving this opportunity. I would like to ask one question. What is your way forward in terms of defining the scope of joint collaborative work, and what will be the objectives, and what are the expected deliverables we are targeting uh, through the joint collaborative efforts? Will you able to give some kind of concept note at the end of this session? So these are my general kind of expectation. So what is your take on this aspect? Thank you.
Yeah, Dr. Saurav, please.
Yeah, so as I said, we have to identify the common problems. One such common problem can be the CO2 utilization. So I hope that by the end of this conclave, we will be able to come up with at least a project on one common problem, which in my presentation, I also in my recent submission, I talked about CO2 utilization. So maybe as Dr. He also suggested, if we can combine the CO2 utilization and solar, which will kind of accommodate a lot of people contributing with their innovative ideas, that can be a good milestone, I would say.
Dr. Low, can you enlighten us?
Yes, please. Hello.
Yes, please.
Hello, this is Snehasis from here, Hyderabad. So I think you all of you talked very nicely and explained everything. So, but since this is a theme about energy and everything, and one of the presenters actually talk about the biomass and convert it to other energy sources. But apart from the energy sources, say for example, in India, we have a huge problem of pollution. And right now, I mean, I think all over the world also, even in China also, there is a problem of pollution of agricultural waste. And right now I'm an assistant professor, but before that I worked as a scientist at Central Pulp and Paper Research Institute. So what we tried also that to convert that agricultural waste, it could be bagasse or it could be rice straw, anything, to convert into a better byproduct, or maybe say for example, whether we can extract the, say from rice straw, can you extract the silica, and so that, and then you can add it to the valuable product, and maybe even the lignin part also you can make it a valuable product. I think, do you have any insight on that, and what could be the major problems, because when you try to extract those, there is a huge problem in pilot scale extraction. So what is your insight on that? Please highlight. Thank you.
So, Dr. Pinjari, may I
Yeah, yeah, please,
answer
please,
this?
please, please,
Okay.
please go ahead.
Okay, so yesterday in my presentation, I talked about the comprehensive utilization of agricultural waste, which I am doing currently with one company. And this agricultural waste is mainly the tree prunings, which we are getting from the municipal corporation areas, and also the agricultural waste like rice stalk and the wheat straw and other things. There are three aspects to this. One is understanding the variations in the composition of biomass. The second is the reactor systems which we are handling right now. They are designed for liquid solid or liquid liquid systems, and mainly to make it profitable, we need new reactor systems. So that is what we are focusing on. The third aspect is the lignin. So lignin mainly I would say it is a self-healing polymer. So if you kind of try to break down lignin, it will find alternatives to kind of repolymerize. And so there has to be a technology which kind of accommodates this repolymerized lignin as well. So for example, we have found that when the lignin, even though if you are while breaking it down, even if it is repolymerizing, we can actually have some functional groups developed on it, which alters its grass transition temperature and alters its properties to fuse with other virgin polymers. And so we have to find applications with such kind of repolymerized and restructured lignin, like create some value out of it, which will, and then the value creation will drive the kind of the other aspect of the energy generation from biomass. So I had talked about a new metric called V factor, which we had developed considering the capex, opex, and other factors. And if you kind of see for biomass mainly, you have to have at least 10 times the addition, like 10 times the value addition to make it, like at the R&D stage, to make it economically viable at the pilot and demonstration scales. So unless we have that 10 times value addition at the R&D scale itself, we cannot expect this biomass to be a reliable resource to be utilized. Yeah.
Yeah, and any questions?
Morning
Any
to everyone. First of all, you have presented very well. So there is a simple question from my side. It's like we are heading for the sustainability, and it should focus on the three pillars like social, economic, as well as environment. So my question is that now photocatalysis is a very prominent field where everyone is working, and like nanomaterials are incorporated with it. So whether some of the nanomaterials are either toxic or they are not economically feasible or cannot be used in the pilot scale processing, right? If we further go for pilot scaling. So can we like head for something like a bigger thing with nanomaterials, like for pilot scaling? Uh, like we have to combat this economical as well as environmental issues of materials. So can you all share the idea of going for a pilot scale?
Dr. Lee hai is available. Dr. Lee hai.
Sorry, I did not get the question clearly. Can you just repeat the question shortly?
Yeah, sure. Actually, wanted to know that, like nowadays, photocatalysis are used predominantly, and
Yeah.
we use nanomaterials for that. So,
Yes.
we for sustainability, we have to head for like socially, environmentally and economically also. All the three pillars has to be focused. But
Yes.
some of the materials are either toxic or economically it is not feasible. Or for pilot plants also, if we go for that area, like it's not that much successful right now. So can we head for such things like looking at the three pillars, focusing on three pillars? Can we head into such pilot plans further?
Thank you. Thank you. I think you have made a you have raised a really good question. Is you're talking about the which is the cost and the stability and the toxicity of nanomaterials. I think we actually we look in industries. Actually, lots of nanomaterials are already used in the chemical industry. I think in terms of the cost, it's really relies in the lifetime of the catalyst. So if your catalyst can work for 10 years, and it should be not a problem. If your catalyst only works for like a day or a few days, then there could be a problem. So in our research, we always care about the stability and the cost of the catalyst. I think from our point of view, we don't need to worry about the toxicity at this moment. So we normally use like nanomaterials of noble metals and non-noble metals, and these are not toxic if unless you like kind of like you eat it and or you leave it in the water. Otherwise, toxicity should be okay. And in terms of the cost, as I mentioned, it really depends on the performance and the lifetime. So if you have the really good catalytic performance and you have a good lifetime, you have a long lifetime, I think this should not be a problem. I think the cost actually, we actually estimate the cost of vertically processes, and in most of the cases, the materials cost is not the major part. The major part could be the reactors and the like sub gases and the separations of gases. And actually, I think materials wise should not be a problem. Just my opinion. Thank you.
Yeah, Dr. Patankar, you would like to add something into that?
Yeah, definitely. The lifetime of a catalyst is a serious issue in terms of the cost effectiveness of the process. The longer the lifetime, lower the cost. And so the robustness of a catalyst is what, in the new catalysts which are being synthesized, the robustness of that is one critical aspect which needs to be demonstrated and confirmed before going into the pilot and into the commercial manufacturing. So there are very, like, if you kind of start with 100 candidates which are giving very good efficiency on the robustness parameters, only 3 to 4 out of them might succeed, which will end up in the commercial stage. And so and which will be like economically viable, as Professor Hay said. And so it's a long process to make sure that the catalyst is robust, and therefore it takes time to go from this R&D scale, like from the technology readiness level, I would say 4 to 7 or 8. So the most of the time is spent in proving the robustness of the catalyst with respect to the reaction conditions. Yeah.
Yeah, any questions from the uh, audience?
Hello everyone.
Yeah.
My question is what's the actual status of sustainable energy as for now, and how can it act as an alternative for the conventional energy?
Dr. Patankar, again, you like to continue?
Yeah, so the current technologies which we are using, so if you see the history of energy, the humanity started using the first kind of resource which we were using for lighting was whale oil, right? In UK, in Europe and America, if you see, the first kind of inventions in using light source was the whale oil. And then you see how this the history of energy has been. Like the whale oil, we stopped using it because we got something like coal, we got something like kerosene, we got like oils out of hydrocarbons. And then the problem with the whale oil was that initially they were able to get they were able to find whales very near to the coast, and then the whale oil was cheaper. And then as the exploitation of this whales went up for the whale oil, basically people had to go far away into the deep sea, and then while coming back, this whale oil used to get bad, and then there were issues with respect to it. And so that kind of accelerated the innovations in terms of getting the resource on the land instead of going into the sea. And so this has been a history of if you see the history of energy, it's mainly driven by one parameter, which is cost, the second parameter, which is the accessibility. Unless this current form of energy gets really expensive and gets really unaccessible to us, there is a I mean, exploiting new forms of energy is and making them economical over the current forms is not a very easy thing to do unless there is a complete shift in the accessibility or the cost associated with this the current form of energy. So with respect to the current form, we are using coal, we are using oil, which is still readily available. uh, so one way of sustainability is using it in an efficient way. So only the changing the resource is not always the best or the sustainable option. Like only the using renewable resource might not be the only way of sustainable energy. Using the current form of energy in the highest efficient way is a form of sustainable energy as well. And so currently while the research is on for using renewable resources, one way towards sustainable energy is increasing the efficiency of currently used resources. So I would say, as we explore the new resources and make it efficient and comparable to the current form, uh, we need to also continuously increase the efficiency of the current resources. So these are the two aspects of sustainable energy, and you can compare the yields of petroleum refineries, for example. What were the yields in 1960s, 70s, and what are the yields currently? How much utilization we are making? See the crack spread in petroleum refineries and how it has been increasing over the years. So we are using every drop of oil now. So each petroleum refinery uses every drop of oil. Initially, we were not using natural gas at all. It was being flared, right? And so now we are having liquefied natural gas. We make chemicals out of natural gas. There is a whole petrochemical complex which is coming up out of based on natural gas. And so this is kind of a sustainable energy in its form, in its current form. So that is my submission. Thank you.
Yeah.
Yeah, good morning, everybody. I'm Dr. Alturi Avanti. I have a question to you all. As we all know that biohydrogen is one of the potential bioenergy forms. So I would like to know your opinion on the hydrogen economy and whether is it feasible and whether biohydrogen can be commercialized and could be a sustainable energy alternative.
I think Jada Shankar is available. Hello. I think Saurav, again, you have to back.
As I said, with the hydrogen, the main issue is with the safety, and so unless we address those issues as engineers, getting that technology into mainstream is getting really difficult. Uh, with respect to the resource which you are talking about, the biohydrogen, again the yields, increasing the yields of it is one aspect, and then dealing with the residue after extracting hydrogen is the second issue. So uh, yeah, so with respect to the cost effectiveness of the technology, again,
Yeah.
I am coming back again and again to the cost effectivity, because that is what sustainable energy is all about. Like I had read like there was a book by a professor from University of Washington in 1970s, when US was trying to make oil from coal, right, instead of like when the petroleum prices were really, crude oil prices were really fluctuating. And then he was trying to like there were efforts to make oil from coal instead of using it for electricity generation. And then there was a justification given in those days that energy is equal to happiness. And so in order to like uh, supply the energy is like supplying happiness to people. And so that happiness people want at a minimum cost as well, because at the higher cost that would really not make them happy, right? So the sustainable energy, all aspects boil down to the cost effectivity aspect of it.
Yeah, thanks, Dr. Patankar. Dr. Jada Shankar, you would like to add to the submission of Dr. Patankar? Yeah, Professor Lihe, you would like to talk about something about the biohydrogen generation and its economy?
Not too much. I think just want to add it up. So if we have one day we really have hydrogen economy, I think I want to connect with CO2 economy, because we want to use hydrogen as for us. Yeah, not too much. Yeah, that's the only thing I want to add. Thank you.
Thanks. Next question, please.
Yeah, one aspect I would like to
Yeah, please,
talk
please.
about the thermal efficiency versus the carbon efficiency. So, as Professor he said about connecting it with the CO2, like in terms of the thermal efficiency, hydrogen usage is really kind of glorious, I would say, because there's no carbon associated with it to like pollute the environment or anything. But at the same time, as I said, what we do with the residues when we talk about like after extracting the hydrogen, so the residues which are mainly going to be carbon rich can go to CO2 and then further utilization pathways. So as he said that it can be a good connection of extracting hydrogen, using it for energy, and then the residues again going to CO2 and then making chemicals and energy out of it.
Yeah, that's good. Another questions, please.
Yes. Good afternoon, everyone. Myself, Anchal Garg. My question here is can you please enlighten some facts on the policy? What kind of policy are needed in order to support the sustainable green energy resources? Can anybody has any idea?
Professor Lee hai.
From my point of view, it's not too much about the policy. It's really about the economic feasibility of this technology. So you have to be economically feasible, and then it can be used practically. And in terms of policy, I think we just maybe the government should just encourage, and at the early stage, particularly, the government should make some investments to support the development of this technology. For example, the government should provide more fundings to research working in this area. That's something I want to just want to say. Not too much. Yeah, thank you.
Dr. Patankar?
Yeah, sure. So from the policy perspective, there has to be an encouragement from the government, and I would say the Stone Age did not end because of the non-availability of stones, right? So if we have to get rid of the current ways of using deriving our energy, there has to be some other kind of like I would say some kind of incentives available to promote these alternatives. So one form which is really effective is the carbon taxes. So tax people who are not using high efficiency processes, who are relying on older technology, not increasing their efficiencies. So it is really important to tax for the carbon emissions. The second is setting pretty steep standards in terms of, or goals in terms of utilizing these alternatives. So unless there is a target set for say using 25%, 30%, 40% ethanol or something, there will be no kind of push from the technology inventors point of view to kind of create new technologies to make this ethanol or anything available, like the alternatives available. So unless there is a need, there is not going to be enough research. And so the need creation of this need is what the policy can do. And so one change in the policy can be the taxes for low efficiency operations. The second can be creating targets to achieve something which might seem unfeasible at this stage, but that unfeasibility really drives the research and development work. Yeah.
Dr. Luo from Yunnan, you would like to add into this? Dr. Luo. Can anybody add something about, say, intellectual policies which are required for the collaboration? What's your opinion, Dr. Patankar? I think everybody is not responding.
Yeah.
Dr. Ilya from Russia, whether he is available? Dr. Ilya?
Yes, I'm available. Good morning.
Yeah. Good morning. The question asks about the policy which is required for the and benefits the SEO countries, considering the young scientist perspective. Would you like to add something to that, please?
Yes, thank you very much for this opportunity. I agree with all the participants about the policy that we have to support our research teams, our science in all the states. It doesn't depend from the country. But what I like to add that actually the state and government is responsible for development of this policy. And as our colleague said, that taxes, for example, can be reduced. And I have to say that state is ought to create some kind of collaborations with industry and research. So I think that if there are no collaborations between, for example, fundamental science, research institutions, universities, and industry, it will be impossible to create any policy in this field. So industry should understand that they can do actually nothing without research teams and science, as well as scientifically it is impossible to create any technology and to promote it to real lives of our countries, of our states, without industry. And this is, in my opinion, very important thing. For example, in Russia, we have a problem of the break between science and industrial companies. And it is really very, we have find really fortune if, for example, one company begins to collaborate with the scientific institutions in one of the fields. And this is, in my thing, in this case, the main problem. So we have to apply different recommendations for industrial companies. State should lead the process of collaborations between industry and science. We have also reduced taxes for the companies which support such kind of policy. And of course, we have to support foundations and science in this field in all our countries, as well as inside the state and also in the international level. Thank you.
Yeah, thank you, Dr. Ilya. Professor Lu.
Yes.
Yeah. Would you like to add into this about the policies required for the SEO countries, considering young perspective?
If we talk about the intellectual property protection, so I think the IP protection is quite important, especially for the researchers, for the academic area. But sometimes we notice that there's not very a clear gap between the collaboration and the IP protection, because sometimes the corporation can have the possibility to leak the IP, but I think for some like fundamental research, when we see products out there on the market, it has probably a very long time to invent it. So I think in the initial stage, the IP protection is more important than it is in the latter stage. The product or the invention is more closer to the market, and the cooperation it requires more. So especially when we have SAO international corporations, of course, the IP protection is very important in each country, but sometimes we also need to pay attention to the cooperation. And so in my presentation, I talked about the importance of doing the demonstration or the pilot project. That's actually is not it go against the IP protection procedure, but I think somehow it can brings you a larger market. So it's really, how can I say, it's really a balancing between the protection and the collaboration. We should pay more attention to the original invention, especially at the fundamental stage, fundamental research. But in the latter stage, when it comes to the market, we should pay more attention on the collaboration, and that brings you the economic benefits and also the market. Thank you.
Okay, Dr. Patankar, you would like to add?
Yeah, so
yeah, can we conclude or we'll continue for some other time?
Yeah, just last. Dr. Patankar would
Last
like
comment.
to comment,
Yeah, I
please.
would just like to say that in terms of the policy to drive this sustainable energy, the targets need to be coming from the government and setting really challenging targets. And then the technology will be developed by, has to be developed by academicians. And then the research for this needs to be really funded by the industry, because unless the industry funds such research, there will be no driving force for taking it from technology readiness level 4 to 8. So the IP needs to be shared between the academicians who develop the technology and the industry who sponsors this technology. And so the from the policy end, I would say the government needs to really set harsh targets for us, and then uh, we should be left with the job of developing the technology which is funded by the industry. Yeah.
Over to Professor Panigrahi.
Yeah. Thanks, Dr. Deepak. So you have conducted it very nicely, and all the people
Thank you.
with so many idea pertaining to the energy and storage. But one of my point I want to tell everyone is like Dr. Pattinger has told, we have to look into all the aspects. We have to look into the production of the energy, different vectors of energy, and also storage. Then ultimately, which I have emphasized yesterday also, we have to take it into some level that which can be demonstrated. Okay, that TRL comes there with protecting the IPs, the policies, and etc. So let us join together, and we have to do something for our country, as well as we try to do something for our country, again in collaboration with all the stakeholders of SCO countries. So thank you. I thank all the participants who have actively participated. Thanks, Dr. Arvind, who has asked a very pertinent question in the beginning, and all the gathering here. And special thank to all the participants who have participated from SCO countries and India, and for the nice conduct presentation and this meeting which was conducted by Dr. Deepak. Thanks, Dr. Deepak. That is
Yeah,
from
thank
my,
you.
yeah.
Thank you so much, everyone. Well, yes, this is the time for a little break, and then we'll be back with the thematic session 3. That's going to be all about biotechnology and bioengineering. So till then, there is a break till 12:15. So I'm hoping we all will be back sharp at 12:15, and then we're going to be starting the next thematic session 3. Thank you so much. Have a great day ahead.